Problem 9. Problem 9, we are given this right angle triangle and we have this perpendicular dropped from the vertex of the 90 degrees to the hypotenuse. When we see something like this, you always have to remember the proportion of the similar right triangles, the one which we use the what we call the geometric mean. So we can use QP as geometric mean, we can use QS as geometric mean, we can use QR as geometric mean. If I'm using QP as geometric mean, then I'm going to write it like this. QP equals QP. Then I use the segment close to the QP, SP. Then I use the whole hypotenuse, PR. So that's the proportion I'm going to use over here. Then I plug in the values. PS, that's what you want to find in part A. QP, that's 10. QP again, that's another 10. The whole hypotenuse, 36. Cross multiply to find PS. So 36 times PS equals 10 times 10, which is 100. Divide both sides by 36. So PS by itself equals 100 over 36, which is approximately 2.78. That's part A. Part B, we want to find QR. So I'm going to write another proportion with QR. So I write QR on the bottom. I write QR on the top. I'm using QR, so I use the segment close to the QR, which is RS. Then I use the whole hypotenuse, which is RP. But RS, how long is RS? I don't know how long is RS, but in the previous part, in part A, we did find that PS is approximately 2.78. So if I subtract that 2.78 from the whole 36, I can find RS. So let's do that first. So RS equal the whole 36 minus 2.78. Approximately equal 33.22. So now I can take that value and plug it for the RS. 33.22. RQ, that's what we want to find. RQ, same thing. RP, that's the hypotenuse, 36. Cross multiply, RQ times RQ, that's RQ squared. 33.22 times 36. So RQ squared equals 1195.92. I want to find RQ by itself without the squaring, so I square root both sides, so I get RQ equals square root of this number. Using calculator, it's approximately 34.58. That's RQ. So we know this part here is 34.58. Part C of the same problem, we want to find QS. When I want to find QS, I use QS as geometric mean, so I write over QS equals QS on the top. Then I use the segment close to PS, close to point S, and I use the segment close to point S. I don't use the whole hypotenuse this time. So I use SP and I use SR. So QS down here, QS over here, then the two segments, SP and SR. Let's plug in the numbers. Do we know how long is SP? Yes, 2.78. We got that from part A. QS, that's what we want to find. QS, that's what we want to find. SR, we did find SR before. Here it is, 33.22. SR, 33.22. We did find that by subtraction. So I plug it in here. Now cross multiply, QS squared equals 2.78 multiplied by 33.22, which is going to give me this number. I want to find QS by itself, so we square root both sides and we get 9.61. And that was part C. Problem 9 has also part D. Do you want to know what is tangent angle R? Here is angle R. Tangent, remember SOHCAHTOA, tangent, opposite over adjacent. So I'm going to use that big right angle triangle. The opposite for R is going to be the 10. Imagine that's not there. So the opposite is going to be 10 and the adjacent is going to be 34.58. So 10 over 34.58, that's the value of tangent R. When I do the division, tangent R approximately equals 0.289. Problem D, part D, for the same problem, we want to find what the value of this angle R. When I know the value of the tangent and I want to find the angle, we just do inverse tangent. So angle R, its value equal tangent minus 1, 0.289. Using calculator, make sure the calculator is set on degrees. Then R equals 16.12 degrees. Problem 11, we are given this quadrilateral. This is 3x plus 2, 3x plus 2, so they are congruent. 4x plus 5, 4x plus 5, it's congruent. When these two sides are congruent and these two sides are congruent, but the opposite sides are not congruent, it's not a parallelogram, of course. We call it a kite. So the question here, what's the name of this figure? Is it parallelogram? Is it rhombus? It's what? And say the reason. So since each pair of consecutive sides are congruent, but the opposite sides are not congruent, the figure is called a kite. And you can go back and watch the tutorial for the trapezoids and kites, and you can figure out this. Now we want to solve for x. When this is a kite, the two diagonals are not congruent, but the diagonal going between the two congruent sides divide the angle and also divide the other diagonal. So only one diagonal is bisected, this one. So now I can set 2x minus 1 equals x plus 4, subtract x, because I have x on both sides of the equation, so I need to eliminate x from one side. So subtract x, then x by itself going down here, bring down the 1, subtract x, x is gone, bring down the 4, add 1, the 1 is cancelled, you get x equals 5. Find the length of the longer side, that's part C. Which one is going to be longer? That's 3x and adding 2, that's 4x, which is more than 3x, and adding 5. So this is the longer. So just plug in the value of x, which is 5 over here. So 4 times the value of x, 4 times 5, 20, plus 5, 25. That's the length of the longer side.